There are many types of acid rain. It could either come in carbon dioxide, nitric acid, but most importantly, 75% of it comes from the presence of sulfuric acid in rainwater. You may be thinking this is a little bit dramatized, but in truth, it really isn't. The burning of fossil fuels results the sulfur dioxide to release into the air, and then when it reaches into the atmosphere, it oxidizes to first form a sulfate ion. The sulfate ions will join with the hydrogen atoms in the air to form sulfuric acid. Eventually, it will fall back into Earth as a form of rain precipitation, and that is what causes the acid in the rain. But natural factors are not to blame for this, because the biggest contributors of sulfuric acid are mainly human activity, which is the combustion of sulfur-containing fossil fuels in power plants, vehicles, and basically anything that uses coal as a source to generate electrical power. This includes mainly automobiles, buses, and anything in the industrial world. Of course, there's some sulfuric acid still comes in small quantities from biological decay and volcanic eruptions, but they have very little impact on the overall acidity of the water. Acid rain comes in two different types of forms, wet decomposition and dry decomposition. And as the name suggests, the wet decomposition happens when the wind blows all the acidic chemicals found in the air to where the weather is moist and wet, and so the acid rains occurs through rain, sleet, fog, snow, or mist. The acid will fall through the ground, mix up with streams, rivers, harming marine life in general. For the dry decomposition, the wind blows the chemicals to areas where the weather is dry, and so the acidic pollutants will turn to smoky, dusty little particles that will stick into all surfaces such as cars, homes, buildings, etc., which at the end gets washed away by rainstorms and back into the streams. 50% of acidic particles in the atmosphere end up stuck to surfaces in the lithosphere. These are carried away into the environment also by rainstorms, rain, and any sort of precipitation. The long-term effects of acid rain can be devastating and irreversible. The result of acid rain falling causes great harm to the environment. For aquatic and marine life, whether acid rain falls directly into the lakes and oceans or into the soil and gets carried down by a stream, they will lead back to the lakes by the stream or by evaporation precipitation to another region. Over a period of time, the accumulation of acid in water will lower the overall pH. Aquatic plants and animals need the water pH to about 5 to live comfortably, but the acid rain can have a pH as low as 3. Any pH lower than 5, fish eggs wouldn't hatch, and gradually 75% of fish species will disappear after a tiny drop of pH in a lake. But other than the obvious of only of aquatic life being harmed, the forests and soils are also at risk. The acid rain kills trees, not by direct contact, but by dissolving the vital nutrients and minerals in the soil that the tree needs to live, while releasing toxic chemicals such as aluminum. When the trees absorb these harmful chemicals, their growth becomes stunted, their protective wax layer becomes fragile, they are more vulnerable to insects, diseases, and weather changes. The unnecessary extra hydrogen ions from the acid rain leach away the soil's natural nutrients such as calcium, magnesium, while also harming microorganisms in the dirt. With an unhealthy soil, the vegetation will be weak. That means less animals, thus shuttering the entire ecosystem. But if you think that's not going to affect civilization, you're mistaken. The dry decomposition of the gaseous particles causes serious respiratory problems when inhaled into our human lungs. The sulfur dioxide in atmosphere may cause asthma and bronchitis. Acid rain erodes buildings made of marble, limestones, and is corrosive to metals, coppers, steel, iron, and so much more. These effects can be commonly spotted on statues, gravestones, historic monuments, and other damaged infrastructures. Although there is not much that we could do for the ecosystems that are already ruined by the acid rain, we can somehow restore a little bit of the damaged environments. For example, we can use a process called liming for the lakes, rivers, and brooks, adding lime, which is very alkaline, to a very acidic surface of waters. It balances the acidity. This helps to keep the pH of water at optimum level. But the thing is, liming is an expensive method and it has to be done repetitively. And also, it's very short term as well. This is not the best solution when it comes to stopping acidity of rain. Another solution could be the use of scrubbers, also known as flue gas desulfurization. It typically works to chemically eliminate sulfur dioxide from the gases leaving the smokestacks. It can eliminate up to 95% of SO2 gases. But these methods are simply called emission reduction strategies, and they're not a way to permanently eliminate sulfur dioxide in our air. So, what is the best choice that we have for our resolution? Alternative energy sources may be the best choice, but may be the most difficult to convert to. It includes, instead of the burn of fossil fuel, there is a wide range of alternative energy sources that can generate electrical power. This includes geothermal energy, solar energy, wind energy, hydropower, and nuclear power. The future health of our ecosystem is dependent on how we use our energy sources, meaning eventually we will have to convert to more renewable energy sources for the protection of our ecosystem and our future.